Right, hello everyone. So, going to have go through a few papers here, see how we get on. So this is a 2020s paper, I think. So a couple agreed to take out a 250 grand mortgage in order to purchase a new home. The loan will be paid back monthly over 25 years, with the repayment due at the end of each month. Obviously, the bank charges are annual and is equivalent to a monthly of 0.287. Use the formula or otherwise find the couple's monthly repayment. Okay, so we want the monthly repayment. So this is our straightforward formula. We don't have to divide across like we did in the previous video. So we just want the amount. So the amount is always going to be equal to the mortgage by our bit of a formula. Okay, so the amount of the mortgage by, if I remember correctly from the log tables, I bracket 1 plus I to the power of t over 1 plus I to the power of t minus 1. So let's pop in our numbers then. So the amount is going to be equal to, let's mortgage is 250 grand, bracket, sorry, I should have made those brackets bigger, but it doesn't matter, we'll figure it out. The interest, which is, now that's in percent, but what's it in decimal? We add 2 zeros to that, 0.00287, 0.00287, bracket 1. I add those 2 zeros, 1.00287, 1.00287 to the power of 25 years times 12, 300 months over, what do we got here? 1 plus I to the t, so it's this number again, 1.00287 to the power of 300 minus 1. Right. 2% bracket, fraction 0.00287 bracket 1.00287 to the power of 300 over 1.00287 to the power of 300 minus 1, close brackets. So we should have a smaller amount than 250 grand and we shouldn't have an error. €1,244.06. So the monthly repayment is $1244.06. There you go. Nice kind of one to get started with. Right, now here's another, same question, same year, another couple, for want of a better word. Okay, so let's see what these people are talking about. They don't look as healthy with their finances. So another couple agreed to take out 350 grand at a rate of 0.3% per month in order to purchase a new home. This loan is also to be paid back monthly over 25 years, with the repayment due at the end of each month. The amount of the repayment, so they give us everything here. Okay, after 11 years of repayments, the couple receive a financial windfall. They decide to repay the remaining balance on the mortgage. Write down the series, including the first two and the last two terms, to show the total of the present values of all the remain of the 14 years after the remain. Oh, Jesus. Hence, find out how much you need to repay to clear the mortgage entirely. Okay. Right. So let's try and figure this one out then. Let's see, what do we got here? 300, and you're taking away 11 after 11 years. 11 times 12 minus 3, 168. Okay, so you've got 168 payments left to go. So the first payment is obviously going to be 1771 over 1.003 plus 1771 over 1.003 squared plus 1771 over 1.003 to the power of 167 plus 1771 over 1.003 power of 168. That's what's left. If we're if what it doesn't, no one cares what they've done beforehand. This is their mortgage now. You know what I mean? This is what we're doing right now. So what do we got here? We need to add these up, don't we? You know, we're summing these all up. So let's try and figure it all out. It's just a bracket 1 minus r over 1 minus r. You know, it's yeah, that's all we're kind of doing here. So your a is just 1771 over 1.003 bracket 1 minus r. So it's 1 over, what is it? 1.003 to the power of, what's it, 168 over that's it. You know, you're just summing all those ones up. You know, it's nothing too fancy here. A bracket 1 minus r to the n over 1 minus r. It's the same thing. So let's say multiply by fraction. Oh god, fraction again. Or 1.68. Hope I might have to use more brackets on these, but I'm hoping not. 1 over. Right, so repayment, how much is it? It should be a big number. Please be a big number. It is 233,000. So the repayment is 233,438 euro and 25 cent. That's how much they have to pay back. Okay, so that's how much they have to pay back. So that's the mortgage bit. Okay. Nice, pretty cool. Nice. Oh, there's another bit to this. Okay. Nice. Acme Confectionery Company have an employee pension scheme. For an employee who qualifies for the full pension, Acme Confectionery Company will pay a sum of 20 grand on the day of retirement. It will then pay a sum on each date in the subsequent year for the next 25 years. Each year, the employee pays a sum that is 1% more than the amount paid in the previous years. What sum of money must the company have set aside at their retirement in order to fund this pension fund? I think Acme is going to go out of business, but anyway, assume an answer of 2.4. Okay, so first of all, first day, they give them that amount. So that's set in stone. And then each day after that, well, isn't it just going to be, you know, I'm trying to think now. The next sum is going to be each year the employee is paid a sum that I think of that. He's paid a little bit more. So instead of being paid this is what we usually do. But there's actually a little bit more each of those times, isn't it? So what's that? 1.01. It's not plus, it's multiplied by it. So that's the little bit more, and then we do our normal thing. Plus the next one would be the same thing again. Right up to the end. And what's the end? It's 25, isn't it? Up to, Jesus Christ, it's going to be huge. So we're going to add all these up right up to the end. That's the crazy bit. What company would put that in play? My God. Anyway, so let's try and work this out. Okay, we have an A. Let me think. What's our R going to be? Well, it's 1.01. That's, you're multiplying that each time on the top, and you're also multiplying, so it's 1.01 over. Yeah, geez, I'm just thinking of that. That's huge. So yeah, that's a crazy amount. Right, so listen, we'll tidy this all up because, what we can do is we can factorize out stuff and then we'll make it easier. So we can factorize 20 grand out, okay? And we've got left with 1 plus, and then each of them is just going to be 1.01 over 1.024 plus 1.01 squared over 1.024 squared. So you can see where that's going. So what you're multiplying by this, so A will be, let's take this at 1, make it easier. R will be 1.01 over 1.024. I'm not going to work that out. I'm just going to leave it as it is. And then T is going to be whatever, is it 25 years? Or is it going to be 26 because you've gotten one for the 25 years plus the 20, so it's 26. Yeah, there's 26 of them. Each year we'll pay a lump sum plus, yeah, I see it. So now let's put these all in. So what have we got? Remember the answer is going to be multiplied. So it's A bracket 1 minus R to the power of n all over 1 minus R. It's that usual one. So it's 1 minus R power of n over 1 minus. And all that thing is going to get multiplied by 20 grand. So it is. Which is crazy. Absolutely crazy. Right, let's do this. 20 grand, bracket, fraction, 1 minus fraction 1.01 over 1.024 to the power 26 over 1 minus fraction 1.01 over 1.024. And please work, should be a huge number. They have to put it, oh my God. So the company has to put aside €440,132.40 in order to fund that over the next 25 years. That's a crazy amount. I suppose it depends on the company. If it's like Google, it's not a problem. But if it's Buckle down the road here, massive issues there. Right. That's crazy. That's absolutely crazy amount. Yeah, when you think about it, that's absolutely crazy. Anyway, that is crazy. Just thinking about that one. Right, try another one. Right. When a loan P is approved, you get this. How is this formula derived? Okay, so this is our mortgage formula. In other words, how do we get our mortgage formula? Okay, we already know that P is equal to A over 1 plus I. That's our standard. Okay, plus A over 1 plus I squared plus A over 1 plus I to the power of T. So that we know that from the basics ones. So we have an A, we have an R. So A is equal to A over 1 plus I. R is equal to 1 over 1 plus I, and T is equal to T. So let's put them into our formula, and so Sn, so in this case P is equal to A over 1 plus I multiplied by A bracket 1 minus R, 1 minus R to the n, all over 1 minus R. So that's where we are at the moment. Okay, and again, what we're going to do is when we move this across the end. So if you remember correctly, what we do next, I'll try and make this smaller now so everyone can see this. So P is equal to A over 1 plus I. Now, we're going to distribute the T in. So we're going to get a common denominator on the top, the big fraction, another common denominator on the bottom. Common denominator on the bottom is going to be 1 plus I, and you're just going to be left with, if you can remember correctly, you're going to be left with I. When you work all this out, I think it's I over. Check that out. 1 plus I minus 1. Yeah. So you left with I, that one. And then in this one, you're going to left with 1 plus I to the power of t. And remember, it's going to multiply by all that. And then you're going to have 1 plus I to the t minus 1. Okay, so what's our little trick? Our trick is multiply that by the top. It's going to cancel with that. So that gets multiplied by there. So that's going to be equal to, it's equal to a over 1 plus I multiplied by, I'll do this, 1 plus I multiplied by 1 plus I to the t minus 1 over I times 1 plus I to the t. Okay, so they're going to cancel. So you'll get P equal to A times 1 plus I to the t minus 1 over I times 1 plus I to the t. Okay, so that's where we are at the moment. Now, how do I make that look like that? I'm just going to divide that. So by dividing that, you're just inverting it. That becomes A equal to P divided by 1 plus I to the t minus 1 over I times 1 plus I to the t, which is equal to P times, P times I 1 plus I to the t over 1 plus I to the t minus 1. Don't need that one there, but that's that. That is that. Bit messy, but it's done. Okay. Now, have a look here. Alexa has a credit card of £5,000. One method of clearing this debt is to make a fixed repayment at the end of each month. The amount of this repayment is 2.5% of the original debt. What is the fixed monthly repayment required to pay a debt of £5,000? Okay. Well, listen, it's just 5,000 at 2.5%. 10% would be 500, 250, 125. We need a calculator for that one. Fair enough. The APR charged by the debt by the credit company is 21.5% or 3/4. Find it the monthly. Okay. Well, I've done this before. Okay. We're going to get the 12th root of that and take away 1. Okay. So that is, let's try and work that one out. 12th root of that. 12th root of, what is that? 1.2175 and take away 1. So you're talking about 0.0, so which is 1.65%. Oh, that's crazy. That's crazy. Oh my God, poor fella. Right. So Alex pays the fixed monthly each month, but does not have any further transactions on that card. Complete the table below to show the balance of the £5,000 is reducing after the first 3 months, assuming this is compounded monthly. Okay. Right. So let's try and figure this one out. So we've got £5,000 new balance, fixed monthly. So it's 125. That doesn't change. So what's the interest on each dash? So you're talking 82.50. And now we're starting with 125. Interest on that. 8180. So I'll take that. We've got 4320, and you've got 491430. The same thing again. You've got 81. Oh, no, just come down so slowly, isn't it? You've got 4391, and we've got 487039. So that's not too bad. Okay. My God, that's still, it's come down. That's why credit cards are a disaster. Right. Use the formula derived in the previous phrase or otherwise. Find how long would it take him to pay off the $5,000. So we want the T value, basically. God. Okay. We haven't done this one. So we have the formula from the previous one, and we just need to get T's, basically, and figure it out. So let's see, can we work this one out then? Where's the formula for the previous page? Here it is. Okay, so let's get that formula down here. So A is equal to P bracket I times 1 plus I to the T over 1 plus I to the T minus 1. I can see you already know what's going to happen, how to get a T. We've done this in the very first video. It's logs, isn't it? So let's try and just isolate the T's, because I'm sure they're factorizable out. We'll get them out some way. So let's multiply both sides by 1 plus I to the T minus 1. At least then we're getting that out. So we'll have A times 1 plus I to the T minus 1 equal to P times I bracket 1 plus I to the T. Okay, so it's not too bad. So let's see what we're going to have to do here. I can't see any other option but to multiply it out, get two of them together on one side, factorize it out, and get everything else over. So that's all I can see doable. So let's try and do that. So we'll have A times 1 plus I to the T minus A equal to Pi Pi. Ooh. That's not factorized. No, it's doable. 1 plus I to the T. So that's all one thing, and just bring the P in. Get them all to one side. So let's say we have A on 1 plus I to the T minus Pi on 1 plus I to the T is equal to this other A. So factorize out the 1 plus I to the T, and you're left with A minus Pi equal to A. That means that 1 plus I to the T is equal to A divided by A minus Pi. Doesn't look very nice, but anyway. So log of both sides. Let's go back up here. So the log of 1 plus I to the T is equal to the log of A over A minus Pi. So that means T is equal to the log of A over A minus Pi divided by the log of 1 plus I. So we have a formula. Now just to slot in the numbers. So A is 125 over A minus, oh God, a lot of messiness here. And then that's just going to be 1 plus I, which is not too bad. So, I mean, listen, it's not the craziest formula I've ever seen, but it's okay. You know, you have everything you need there, really. So let's just slot over everything. Let's see if Pi. Right. Let's try it. Fraction. Log. No, listen, we could use logarithms here. I'm not going to go there. A. So let's try and think of that one. That's going to be 125 over 125 minus 5,000 times 0.0165 minus multiplied by point. No, it's too many decimals there. It's 1.65, wasn't it? So that looks right. Put that bracket there. Over the log. This one's an easier one. Just the log of 1.0165. I don't know if this is going to come out at all. Got something here. Get 25. That doesn't seem right. 25 years, 25 months. I'll check it again. Just check I've got the right logs. Log of that over the log of that. 125 over A minus P. 125 minus 66 months. Oh my God, 66 months is like 5 years. Okay. Right, so I forgot to put I just had that bit. I had to have 125 minus it. Sorry, that's my fault. Really, what I should have done is probably earlier on put in the numbers, but listen, I'm just being lazy. Right, so there you have it. That's that one done. Right. Ooh. It's like an epic. So Alex decides to borrow $5,000 from local credit union to pay off his credit card. The APR is 8.5% for the term of the loan. The loan will be paid out weekly for 156 weeks. Same thing again, like, you know what I mean? We're just trying to work out the weekly, isn't it? It's just the same, whatever. So it's 52 weeks in a year. So we need to break down that, and it's 8.5% fixed term. That's the annual, and it's going to be paid back weekly. Oh, so we need the 50-second root of, so 50-second root of 1.085, subtract 1. I'm going to work it out. 1.57 by 10 to the minus 3 is your weekly interest. Okay? Which is crazy. Okay, so let's put it in. Right, so the amount is going to be $5,000 times that number, 1.57 by 10 to the minus 3 on 1 plus 1.57 by 10 to the minus 3 to the power of 156 all over 1 plus 1.57 by 10 to the minus 3 to the power of 156 minus 1. Right, so I'm going to save that. It's saved there, so let's just go for this one. 5,000 bracket, answer bracket 1 plus answer to the power of 156 over 1 plus, oh no, I put that in brackets, plus in brackets 1 plus answer power of 156, take away 1. Oh, I made a mistake somewhere. Where did I make the mistake? Okay, so 5,000 by the answer plus, oh, there's a second bracket there. See it there now. 36 euro and 16 cent. That's the amount you have to pay. Okay. Right. How much will Alex save by paying off the credit card? We're just taking the two numbers from each other. Okay. So, you know, what are we looking at? 125 times 66 minus 3616 times 156. Times 156 equals minus in bracket 125 times 66. €2,609. Okay, so there you go. I should find another one. Right. So, a local sports team on a lotto. I think. No, that's a different question. I don't know where I got that from. Right. I don't know where I got that one from. Now, say. 100% of workers. Oh no, that's the statistics there, but I'm sure there must be something that we read down. No, that's all statistics. Statistics, sorry now. Here we go. Right. Donna is arranged a loan and examining two different repayment options. Bank A will charge him a monthly interest of that, find correct to the annual percentage. Okay, so if that's the monthly, we need to work back up. Okay, so remember, how did we get that? That was 1 minus, that was the 12th root of 1 plus I minus 1. So remember, that was the 12th root of 1 plus I and then minus 1. And that gave us 0.0035. So I'm going to add 1 to it, and I'm going to power 12, and then I'm going to take away 1. So that gives you your kind of answer. So 1 plus 0.0035 to the power 12, and then I'm going to take away 1. 4.28%. There you go. Nice, easy marks if we can get it. Part 2. The bank will charge him a rate equivalent to 4.5%. Find correct the monthly interest rate. So we just go back again. Are you serious? They're just testing you on going backwards. So listen, we know how to go backwards on this. So we're just doing it the other way. So we're just going to get the 12th root and take away 1. 12th root of 1.045, take away 1, and that's multiplied by 100 to get the percentage. That is 0.367%. So nothing crazy there. It's just reversing that process. But this is the correct process, that's the reverse process, but they've done it in the other order. It's a bit weird one. Okay, so here we go. Here's the main question. So Donna borrowed 80 grand at monthly for the fixed term, the loan from Bank A. The loan is to be repaid in equally monthly over 10 years, monthly, so 10, that's 120 repayments. The first repayment is due 1 month after the loan is issued, which is about right. Okay, so calculate correct to the nearest euro the amount. We want the amount. So we've done this before. Amount is equal to, the mortgage by I bracket 1 plus I to the t over 1 plus I to the t minus 1. So let's just pop in our numbers. So we've got 80 grand. I is going to be 0.0035 on 1 plus 0.0035 to, what did I say, 10 years, 120 over 1 plus 0.0035 to the power 120 minus 1. Okay, so 80,000 multiplied by bracket fraction 0.0035 bracket 1 plus 0.0035 to the power of 120 close bracket, because I didn't make that mistake again, over bracket 1 plus 0.0035 close bracket to the power of 120 minus 1. Oh, I made a mistake again. Where have I made a mistake again? Nice. Check where I made a mistake again. 1 plus that to the power of 20. There is a second bracket. Oh, I need a bracket. Sorry, need a bracket at the end. What the hell? That should be right. What's going on here? Right. I'll check it again. Delete that whole bracket then. There we go. Equals 817.59. Oh, to the nearest euro, 818. Okay, cool. Right, that's nice. Now, Baudrick. Baudrick is 25 years old and is planning for his pension. Fair play to him. He retires in around 40 years' time. Poor fellow, when he's 65. First, he calculates how much he wants in the pension fund when he retires. Then he calculates how much he needs to invest. He assumes that in order the long one will be invested in inflation. Inflation, hello, it's about 8%. Rate of 3%. Your answers throughout this question will be based on 3% annual growth rate. Okay, so this is Baudrick, just to keep in mind 3% growth rate. Okay, so write down the present value of the future payment in 1 year's time. Okay, well, in 1 year's time, it's just going to be over, what is it, 1.03? $19,417.48. Write down in terms of t the present value in t years time. So this is the formula. Okay, well, listen, it's the same formula. Okay, so the present value in the future is just going to be the future over 1 plus I to the t. Okay, which in this case is just going to be 20,000 over 1.03 to the power t. That's all we can do there. Nothing else we can really say about that. Now, he wants to have a fund that could, from the date of his retirement, give him 20 grand each year for 25 years. Show how to use the sum of a geometric series to calculate this. Okay, well, listen. At the start of each year, so he wants 20 grand plus, then he wants so he wants at the start of every year, not the end. So that's why we're going to 25, not to 26. Okay, we're going to the end, we'd have to go to the 26th. You know what I mean? But we're not. So let's try and figure this out. So 20 grand, we can factorize out to 20 grand and just go with 1. So there'll be a, in this case, so if we factorize out 20 grand, we're left with 1 plus 1 over 1.03 plus 1 over 1.03 squared, blah, 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 blah. So we can have a bracket 1 minus r, 1 minus r to the n, in this case 25, all over 1 minus r. Sorry now. So 20,000, right, 1 minus 1 over, sorry about that noise, the power 25 over 1 minus, seriously, the one day I do this, please bracket work. Right, we're looking at to the, it doesn't say to the nearest whatever, so that's going to be equal to €358,710.84. That's how much he's going to have in his fund in order for that to work. It's crazy. Crazy. Oh, Park has more to tell us. Okay, so Park plans to invest a fixed amount of money every month in order to generate the fund that he needs. His retirement is 480 months away. Find correct 4 decimal places or 4 significant figures. The rate of interest per month it would need. Oh no, we must. Okay. So we need to work that out in order to get a. So we need to work backwards. It's our usual. Okay, 12th root 1.03 minus 1. Sorry, 12th root 1.03 minus 1. So multiply that by 100 to get the percentage. So we're looking at 0.2466% monthly. Okay, write down in terms of N and P the value of the retirement date, or value on the retirement date of a payment of P made in N months before retirement. Well, listen, isn't it just this? Was it 1.002466 to the power of N? See, now this is probably showing my age. This is where N started to disappear. Probably the last year N was in, you know what I mean? After that became T. Right. So if Porrick makes 480 equally monthly repayments of P, how long until his retirement? All right, so I see it here. So how many values? Yeah. So we have our fund. What was our fund? 358,710.84. Right. So 385. That's 358,710.84. That's our fund, and that's going to be equal to the amount times and our usual stuff. 1.002466 bracket 1 minus 1.002466 to the power of, what are we looking at here? 480 over 1 minus 1.00. Crazy amount of money. But anyway, let's work it out. So I'm going to divide that by that basically. So 358,710.84 divided by in a bracket a fraction 1.002466 bracket 1 minus bracket 1.002466 to the power of 480 over, I know I missed the bracket somewhere, but I'll go back and find it. Close that bracket. Oh, I didn't. Equals €389.22. That's how much he has to pay. Not so bad. Okay. Now, if Porrick was to wait 10 years before starting his pension, how much would he have to pay each month in order to generate the same function? So it's the same bloody sum again, but we've reduced it by wait for 10 years, so that he's only got 30 years now. So 30 times, so that's 360 instead of whatever, 480. So it's the same sum again. Christ above. Like, you know, that's, wish it. Damn it, I got rid of the formula. Okay, it's the same formula again, except we're doing it at 380. Okay, so it's still going to be 35871.84 is equal to the amount on 1.002466 bracket 1 minus 1.002466 by, what is it, taken off? So it's 360, power 360 over 1 minus 1.002460. So it's the exact same sum, except we're doing it one less. Okay, I'm not going to do it again, whatever the hell it is, but it's going to be a higher order, so I'll have to do it again. 358,710.84 divided by a bracket fraction 1.002466 bracket 1 minus 1.002466 to the power 360 over 1 minus 1.002466. Please work. 618. 618.35. Christ, that was a pointless endeavor. You know, it'd make you do all that. I should have reread the next question. That's my fault. Right. Last one then. Neve. Neve wishes to buy a car. Same thing again, isn't it? Show that that's that. Okay, well, listen. I can show it both ways. So the 12th root of 1.04 minus 1 should be 0.00327. So, and then I can reverse the process from either. Let's just check. 12th root of 1.04 minus 1. There you go. Done. All right. Neve has 15,000 in an account at the end of 36 months. How much did she save each month? So this is what we're looking at here. So let's think about it. In order to, we need the amount she saved. Okay. So she must have saved the same amount, you know what I mean? P times 1.00327 to the power of 36 plus P times 1.0037327 35 right back to the power of 1. Okay, so that's what we need to work back out. So whatever it is, it's going to be, so 15 grand is equal to what have we got? 1.00327 bracket 1.00327 power of 36 minus 1 over 1.00327 minus 1. Now, let's have a look. This is, by the way, you can do this both ways. I can have 1 minus that, as long as that's 1 minus that, because that's just creating whatever that number is and whatever that number there, they're in the same ratio, whether they're positive or negative. So it'll work both ways if you make that mistake. So 15 divided by fraction 1.00327 bracket 1.00327 to the power of 36 minus 1 close bracket over 1.00327 minus 1 big bracket. So we're looking for a smaller amount here, 392 euro. 392 euro and 2 cents. Not too bad. Okay, right. Now, last question. Colin borrowed to buy a car. He borrowed 15 grand, and that's the monthly. He made 36. How much to the years here was each of his monthly repayments? Same thing again. Okay, for poor O'Connell. Okay. So listen, 15. What was he borrowed 15 grand? I want to know his monthly. It's the same thing. Okay. What are we looking at here? Sorry. A bit distracted here now on this one. Right. So what we're looking at here, I, which is going to be from Connell 0.1 over 1.0086. I won't do it that way. I was going to do it the kind of other way. No, I won't. I'll just do it the simple way. Okay. So 15 grand. Now we're looking at 0.00866 bracket 1 plus 0.00866 36 over 1.00866 36 minus 1. Same thing again. Okay. This is literally like the same question, except he's paying it back. You know what I mean? It's crazy. Right. Bracket. Let me see. 0.00866 1 plus 36 divided by 1.00866 486, 77. This is repayments. Okay, that's it. Thanks very much. Bye.